Fine, so today's lecture is about the crossover operator. In the earlier lecture, we did the selection operator that is considered to be as the first operator to be applied on the chromosomes, right? Now, in the crossover operator, first of all, we have already seen that we have applied the selection operator. Why we have applied selection operator? We have applied selection operator in the earlier lecture to select two chromosomes which are best fitted to be the parents. That means they are going to be the parents. We have selected the best fitted chromosomes or individuals. Those are being considered as parents and they will mate and create a new child. Now, up till now, their reproduction has been taken place, but child are not created as different, right? So once a pair of parent chromosomes is selected, the crossover operator is applied. Now, first thing, why we are applying crossover operator? What will happen if we are not going to apply the crossover operator, right? So the question arises why, and if not applied, what will happen? So basically, if we are not going to apply the crossover operator, what will happen? The offsprings, the childs which are created will be the exact copies of the parents. They will not be any different from the parents. So child will be exactly same as the parents. So there will be of no use of creating new generation. They will be same as parents, right? So that is why what we need to do is we need to apply the crossover operator, right? Now, how we are going to apply the crossover operator and what actually is crossing over? Now, crossover operator is termed to be as a recombination operator. What does this recombination means? That means when we have two parents, what we are going to do, we are going to swap certain bits from parent 1 to parent 2 and from parent 2 to parent 1 and will create new offsprings with different bits as compared to the parent 1 and as compared to the parent 2. They will not be the exactly same when we are going to swap. They will inherit certain properties of parent 1 and certain properties of parent 2 as it happens in natural reproduction, right? So the reproduction operator selects. There are 3 steps in this particular crossover operator. The 3 steps I'm going to tell you, they are: first thing, the reproduction operator selects at random a pair of 2 individual strings for matting, right? What we are doing, we are selecting the 2 individual strings for matting. Second thing, a cross site is selected randomly along the string length. Now, we have a chromosome length, individual string, and out of this string, let's say we have 0, 1, 0, 0. This is the string we have. This is the one individual chromosome. What I'm going to do, first of all, I'm going to select any site, any specific site. Let's say I have selected this site, right? So what I'm going to do, now I am going to, third step is, I'm going to swap the values of these 2. Let's say I have, this is parent 1 string, right? Then I have parent 2. Let it be 1, 0, 0, 1, right? So first step is I have selected the 2 parents. Second step is I have selected the random site, any site from in the individual string, right? I have selected this particular site and now I'm going to swap the positions of these 2, right? I'm going to take these 3 bits in child. When child 1 is created, what is it? The parent 1 will have the same as 0 and I will swap this particular as 0, 0, 1 here. 0, 0, 1. So now you can see this is not exactly as parent 1, neither it is exactly as parent 2. I have swapped these 2. Now, when I create the child 2, what will I do? I'm going to again swap. This is parent 2, 1 is same, and I'm going to swap. This has already been transferred or swap to this particular parent one, and parent one 100 will be coming here 100. So these two childs are became new individuals. They are not exactly the same. If I am not going to do this swapping, if I am not going to do this crossover operation, then what will happen? I'll get the two offsprings that will be exactly same as of parent 1 and parent 2. What if I have not swapped these bits 001 and 100? It would have been same as parent 1, child 1 will have been same as parent 1, and child 2 would have been same as parent 2. So what I have done, that is why we have swapped. This is the main importance of crossover operation. So this is how it is done in 3 steps, right? Now we will see, this is just an example of crossover operation. Let's say these are the two strings. I have selected this side. This is the side I have selected. And what will I do? 01 will be moved to this place and 00 will be moved to this place. So what will be the new childs? It will be 10. And when 00 is moved here, so it will be 00. Okay. And when this would be moved here, 01 here. So what will I get? I'll get 0. 1 will be same, and 01 is reaching here. So it will be 01. Okay. Now the new what we have got is 1000 and 0101, right? All right. So this is what crossover is actually. Right now, what we are going to see is, we are going to see that there are different types of crossover operations which can be performed. So the different types of crossover operators are, first is called as the single point crossover, second is called as the 2-point crossover, third one as the multi-point, fourth one as uniform, and fifth one it is called as the matrix crossover. Matrix crossover is also called as two-dimensional crossover. Two-dimensional. So matrix is also called as two-dimensional. You have to remember this. We are going to see this one by one, how this is done and what it is about, right? So let's see. First one is the single point crossover. Now in this particular first step is, we have selected the parents, right? Now, what we have to do, we have to randomly select a cross site. So in this string, I have selected this particular cross site, let's say, right? I've selected this particular cross site. Now, when I have selected this particular cross site, this is single point. So that is why I have to only select one cross site in this individual. Now, when I have selected this, after this cross site, whatever bits are there, I have to swap these particular bits, right? And then I'll create the offsprings. So after this cross site, what are the bits? These are the bits. Now I'll create the offspring 1. Offspring will be same. These particular bits will be same as this one, right? So it is 11001, 11001. And I have swapped these two bits. Okay, so here it will be 111. From parent 2, I have made it to offspring 1. So 111. And similarly, offspring 2 will be created as, this will be done as same. That is 00100000100. And I have swapped this from, I have taken this particular part from 010 from parent 1. So 010. So I have created two offsprings. So this is before crossover operator have been applied. Which one? Single crossover. And this one after crossover. So this is how single point crossover is applied. Second is 2-point crossover. So what we are doing here is completely same. The only difference is I am considering, or I am randomly selecting two cross sites, right? So this is cross site 1 and this is cross site 2. So whatever bits are falling between these two cross sites are to be swapped. Others will remain same. So parent 1 is this, offspring 1 will be same as parent 1, 100, 100 and 11, so 11. The only thing is this is being swapped. So I'll write this one from offspring 1, so 1 0 0, right? When I create offspring 2, so it will be 0 1 1 will be same, 0 1 will be same, only the middle part of the two cross sides will be selected as swapped. That is, I'll take it from parent 1, 1 0 1. So I have taken 1 0 1 in offspring 2. So here again two offspring has been created which are not exactly the same copy of parent 1 and parent 2. They are completely different, right? Now considering the third, that is the multi-point crossover operation. Now next one is multi-point crossover. Multi-point crossover has been divided into two. One is even number multi-cross point and second one is odd number multi-cross point. In even number cross point and in odd number cross point, we have to remember whenever we consider the even number multi-cross point, we take the circular form always, right? For even number, we take the circular form, circle, and for odd number, we take a straight line. Right? So here you can see this is parent 1 as a circle and parent 2 as a double line circle. I'll take 2 here. I'll take 4 cross sides, these, and then I'll create the child. So I have taken this part from parent 2, then this part from parent 1, this part from parent 2, and this part from parent 1. So this is how I have created a recombination of parent 1 and parent 2. Similarly, in the odd number multi-point, I will be taking the string, the straight line, the strings of line, right? So again, I have taken, here I'm taking odd number. So there are 3 cross sides. Earlier, I was taking even number. So there are 4 cross sides, you can see. These are the 4 cross sides, right? So I've taken these 3 cross sides and these 3 cross sides are to be interchanged and to be swapped as we are doing in every sense, right? Now, fourth one is crossover, uniform crossover. Now, in this we are going to get a crossover mask. There is a point in which we get crossover mask. When we have a crossover mask, what I am going to do, whenever we encounter 1 in crossover mask, I'll copy the bit of parent 1, and if I encounter 0 in mask, I'll copy the bit from parent 2. So this is parent 1, 1 0 this is, and parent 2 is this one. So when I create child 1, I'll see the mask. Here I encounter 1, so I'll copy from which one? P1. So 1 is copied here. Then I encounter 0. So when I have 0, whatever I'll copy from parent 2. So this is copied from parent 2, not from parent 1. Right? Then I encounter again 0 in mask. I'll again copy from parent 2. So this is 0. Encountered 1. So again now I will copy from parent 1. So I have copied 0. Right? So this is the way I'm going to copy in this format and I'll get a new child. Right? So this is the uniform crossover. Last, I have the matrix crossover, which is also considered to be as the two-dimensional. In this particular, what we have, normally we have the strings represented as one-dimensional array. Here we have two-dimensional crossover. Each individual is represented as a two-dimensional array of vector. Now in this form, we will take a matrix form because this is two-dimensional. So what we have 3 rows and 3 columns in this, and total 9 cells will be there. And these particular parents will have different way of matrix and they will be swapped. See, this is how we have swapped. You can see this particular shaded one is a parent 2 and this is blank one is parent 1, and we have swapped and created 2 new childs. So this is the matrix crossover operator. So these are all the different types of crossover operators. Thank you very much.